Welcome back, Physical Science 20. This is the second FC3 booklet, 12.1, stoichiometric calculations it's called. And for this we'll look at the sequence of steps used in solving stoichiometric problems and use those steps. So explain them and use them. So first of all, using stoichiometry, what are the mole ratios that we'll be looking at? What are they based on? Balanced chemical equations. The chemical equations are the key from going from one reactant or product to an unknown reactant or product. And how do you do? So if you look at, first of all, mole to mole conversions, then we'll look at mole to mass, and then we'll look at mass to mass. With mole to mole conversions, you know that if it's a mole to mole conversion, if you are given the number of moles of reactant or product in a reaction and you want to calculate the moles of another product or reactants, going from moles of one substance to moles of another substance. So if we take a look here, here's a couple of examples. Do two examples dealing with that. First of all, sulfuric acid is formed when sulfur dioxide reacts with oxygen and water. So the balanced chemical equation looks something like that. Sulfur dioxide, oxygen, water, yielding H2SO4, sulfuric acid. I balanced it out here, so 2 to 1 to 2 to 2. And here we have, if 12.5 moles of SO2 reacts, how many moles of H2SO4 are produced? Now, in doing this, I highly recommend that you rewrite the equation, write down what you're given, and then write a question mark by what you're trying to find out. I tend to like to draw it on top of the equation. So moles on top. Moles implies that we're going to be using the balanced chemical equation. We're given 12.5 moles of SO2. We're asked to find what moles of H2SO4, so that's the question mark. So we're going from here to here, moles to moles. Okay, so if I start this out, if I take a look, I'm given 12.5 moles of SO2. Now the mole ratio here, just like in the previous assignment, we're going from SO2 to H2SO4. We want to end up with H2SO4, so that is going to be on top of the conversion factor. And where I'm coming from is on the bottom. So if I'm going from SO2 to H2SO4, from SO2 to H2SO4. And of course, you know if you're doing it right, if you can cancel out the identical unit here. So this is an easy one. It's a 2 to 2 ratio, which is a 1 to 1 ratio, so the number doesn't change. But you need to put this step here because we're given SO2. We have to have a way of converting it to H2SO4 by using the balanced chemical equation. Next, once again, we have 12.5 moles of SO2, but how much O2 do I need to react? So this time it's a scenario like this. We have 12.5 moles of SO2 and we're converting it into moles of O2 once again by using the balanced chemical equation. So if we look here, 12.5 moles of SO2. This time we're going from SO2 to O2. SO2 to O2. So it's a 2 to 1 ratio. So units cancel. 12.5 times 1 divided by 2, 6.25 moles. And of course 3 sig figs there because there's 3 sig figs in the question. Okay, that's basically how you do it. Number 4, the last example dealing with moles to moles. A reaction between methane and sulfur produces carbon disulfide, a liquid used in the production of cellophane. So there's the equation. Letter A. Calculate the moles of SC2 produced when 1.5 moles of sulfur is used. See if you can figure that out. Maybe pause the video, write down what you know over top of the equation, and see if you can work it out by setting up the correct mole ratio and getting the answer. So pause the video now. Okay, if you had a chance to do that, excuse me, there's the equation. So we're starting off with 1.5 moles of sulfur. We're asked to find how many moles of carbon disulfide there is. So as you can see, starting off with that, we're going from sulfur to carbon disulfide. sulfur to carbon disulfide. Moles of S8 cancels, and we're left with what we want. If you can cancel a unit, that means you're doing it right. So 1.5 times 2 divided by 1, 3 moles carbon disulfide. If you look at the next one, how many moles of H2S are produced when I start off at the same 1.5 moles of sulfur? So write down the formula there, and I highly recommend doing this because it will get a little more tricky as you see later on in this booklet. 1.5 moles of sulfur to H2S. So 1 mole of sulfur going to moles of H2S. 1 to 4 ratio there. So 1.5 times 4, we get 6 moles of H2S. Okay, so those are moles to moles. Just simply using the balanced chemical equation to figure out how to go from one substance to another by the mole ratio, like we did in the study guide of 12.1. Okay, now we'll go mole to mass, and then lastly mass to mass. How do you know if you're dealing with a mole to mass reaction? You know it if your reactant or product that you know is in moles and you want to calculate mass of some other product or reactant. So we'll take a look at an example. Titanium is a transition metal used in many alloys because it's extremely strong and lightweight. Titanium tetrachloride is extracted from titanium oxide using chlorine and carbon. Okay, so there's the reaction. If you begin with 1.25 moles of titanium oxide, what mass of chlorine gas is needed? So rewrite the equation. Now you can see it's a little bit different than previously because we still have to go to moles. So we're going from titanium oxide to chlorine, so moles to moles. But the question asks, okay, how many grams of chlorine that is? So what I like to do is write grams underneath. We're going to be popping out of the balanced equation and determining grams. Set up the schematic and you won't go wrong, folks. So we're starting off with 1.25 moles of titanium oxide. So the first step, like before, going from moles to moles, titanium oxide to chlorine, titanium oxide to chlorine. So there we go. And if I was to stop the question right now, doing this first step here, I'd have moles of chlorine, going from one substance to another. The next, to go from moles to grams, you've of course seen it already using the Y chart. It's a moles to mass conversion. We need to know the molar mass of chlorine. So over here on the side I figured that out, which is what I'd like you to do. If you have to figure out the molar mass, just write it off on the side. 2 chlorines, 71.0 grams per every 1 mole. So the conversion, 1 mole of 71 grams. So this is this step right here, the second conversion. And as you can see, the units cancel out nicely, and we're left with our final unit. 177.5 grams of chlorine. There's 3 sig figs here, so I rounded that off to be 178 grams. Okay. 7. Sodium chloride is decomposed into the elements sodium and chlorine by means of electrical energy. Write the balanced equation. Very easy. Chlorine, of course, is Cl2. It's one of the Hofbrinkel elements. There you have it. How many grams of chlorine gas can be obtained from 2.5 moles of sodium chloride? So the scheme looks like this. We're starting off with 2 moles of sodium chloride. We're asked to find grams of chlorine gas. To go from one substance to another within the equation, it's a mole to mole conversion, and then from there, moles to mass. So, starting off with our 2.5 moles of sodium chloride, we can see 2 moles of sodium chloride makes 1 mole of chlorine gas. So if I was to stop right there, I'd end up with moles. One more step, as you can see, chlorine gas again. I figured this out earlier, but I thought I'd rewrite it. Multiplied by the molar mass, cancel, cancel. We're left with 88.75 grams, but of course that's 3 sig figs, so it rounds out to be 88.8. Okay, we'll stop right there. That's part 1 of the video. Part 2 of the video, we'll look at mass to mass conversions. Okay, so we'll see you soon.